everyone, welcome to the discussions of the past year questions. This video we shall discuss about the further mechanics, paper 3, October-November 2023, paper 32. Let's take a look at the first question. One end of a light inaccessible string of a length A is attached to a fixed point O. The other end of the string is attached to a particle of mass M. The string is taut and make angle theta with the downward vertical through O, where cos theta equal to 2/3. So this will be the diagram. The theta. Then it will move in a horizontal circle with a speed v. Okay, so that is supposed to be the diagram. This is the O. This is the mass. This is the weight mg, and this is the tension. Okay, and the length of the string is A. Then we need to find the radius. Since they give you cos theta is equal to 2/3, we can actually draw a triangle. 2 here, 3 here. This one will be a square root 5. Okay, so then if we resolve the tension vertically, we have the T cos theta is equal to the mg. Then your cos theta is 2/3. Then your T will be 3/2 mg. That is the first part of the questions of the solution. Then after that, we resolve the forces horizontally. This time we will have centripetal force. So we will be T sine theta equal to the mv squared over the r. So the r, I need to find the r. The r is actually, we know that the r over the a, it will be sine theta. Then the r is equal to the a sine theta. And the sine theta is a sec 5/3. Okay, so this one we put it here. So now d sine theta, d just now is from equation number 1 just now, d is a 3/2 mg. Sine theta we know is a sec 5/3. M we do not know. The v we do not know. M can be cancelled because this one we have M here, we can cancel it later. But never mind, we cancel it later. No need to cancel it right now. Then the R, as we have found just now, R is a sec 5/3a. So if you, now you can start to cancel. We are looking for the V in terms of A and G. So you have this one, you can cancel it. So you have a sec 5/2g multiplied by sec 5/3a equal to the v squared. Therefore, your v will be the square root of the 5/6ga. Just like that, done. That is the answer for the question number 1. Move on, we have question number 2. A particle P of mass 0.5 kg move in a straight line at time t second. The velocity of P is v meter per second and its displacement from a fixed point O on the line is x meter. The only force acting on P are the force of magnitude 150/x plus 1 square Newton in the directions of increasing displacement. That means it's away from O. And a resistive force of magnitude of 450 over the x plus 1 cube Newton when the t equal to 0, x equal to 0, and v equal to 20. Find v in terms of x. Giving your answer in the form of as given here, where a and b are constant to be determined. Okay, so for this question, we just need to resolve the forces along the horizontal directions, along the directions of the motion. You can see that you have the the force that is moving the object minus the resistant force will be equal to the MA. And the M is a half. So we just write the M as a half A. So your A will be equals to 2. 300 minus I want to make the denominator same. So this one I make it become 300 x plus 1 minus 900 divided by the x plus 1 cube. Okay, then the dy, the acceleration here, I have two choices. I can make it become v dv dx, or I can make it become dv dt. But since they want the answer in terms of x, so we just need to choose v dv dx. So we choose v dv dx, expand first, and simplify. This one, we can get v dv dx. Oh, since in this case, there's no need for us to combine them together. Remain them as this way, it will be better. So no point of combining them because we no need to move the x expression to the other side. So we can just leave it as the form like this. Okay, that would be nice enough. Then this one just write down 300 x plus 1 squared minus 900 over the x plus 1 cube. Then your v dv, it will be equal to the, you integrate v dv, it will be the same as integrate 300 over the x plus 1 square minus 900 over the x plus 1 cube dx. Okay, so I'm applying the result. I'm applying this result ax plus b power of n dx. If I integrate, I will get the formula like this. I will use a formula like this to integrate these two. Okay, so I'm applying this result. So from here, I should be able to get this as the, my left hand side is a v squared over 2. My right hand side will be negative 300 over the x plus 1 plus the 450 over the x plus 1 square plus a c. Then after that, the question giving you that t equal to 0, x equal to 0, and v equal to 20. So given when t equal to 0, x equal to 0, v equal to 20. So that means this one is a 20 square over 2 equal to the negative 300 plus the 450 plus a c. So from here you can find the c. Your c will be 400 over 2, 200 minus 400 divided 2 minus plus 300 minus 450. The c will be a 50. Okay, so c is a 50. Since c is a 50, just replace it back. Like this. Then I multiply everyone by 20. $100. So over here, we can try to factorize it. The question are looking for v, not v square in terms of x. So we cannot leave the answer in terms of v. So by right, we're supposed to square the whole thing over here. But not so fast. We need to simplify our right hand side first. So what we can do here is we factorize the 100 over the x plus 1 square out. So you get this one, it will be x plus 1 square minus the 6 of x plus 1 plus the 9. So if you treat this as a u, then you will get this as a u square minus a 6u. Then this one will be like a u square minus a 6u plus 9. And you know that the u square minus 6u plus 9 will be u minus 3 square. So since just now I say that the u is a x plus 1, I just change it back. So over here, I direct factorize. You can expand. Maybe we expand. So that all of you here can see it clearly. So if I expand them, simplify, I have x squared plus 2x plus 1 minus a 6x plus minus 6 plus 9. So simplify it. One more step, you will get this one as the x squared minus a 4x plus a 4. X squared minus 4x plus 4 can be factorized as the 100 x minus the 2 square over the x plus 1 square. So 100 is a 10 square. So therefore, your v will be the 10 x minus 2 over the x plus 1. But be careful, because we are having a plus and minus over here. So your v have two answers. So we need to confirm which one is the correct answer. So because of the information given, they mentioned that when x equal to 0, v equal to 20. And when you substitute x equal to 0 inside, you will get, in order to get 20, then you must choose negative value. So for this case, have to be careful. So we need to mention clearly. So because of x equal to 0, v equal to 20, therefore my v will be a negative of 10 x minus the 2 over the x plus 1. And we can bring the negative in by making it become 2 minus x over the x plus 1. Done. We continue over here now. Okay, so this will be the solution for the question number 2. That's all. So now we move on. Question number 3. Okay, now we take a look at question number 3. A uniform lamina is in the form of an isosceles triangle ABC with AC is equal to 2A. ABC is 90 degrees. The point D on AB is such that the ratio of DB to AB is 1 to K. The point E on CB is such that DE is parallel to the AC. The triangle DBE is removed from the lamina. See diagram. Find in terms of K the distance of the center of mass of the remaining lamina DADEC from the midpoint of AC. So over here, what we need to do is we will consider this as the x-axis, this as the y-axis. Okay, because they are symmetrical. So the center of the mass must fall into the axis of symmetry, must be somewhere here. Okay. Then we need to find the coordinate of the point here. So this is symmetrical. So this point, this one is origin. This one, it will be A 0. This one will be negative A 0. This one, it will be, the height over here is A, because this one is a 45 degree. This one is a 45 degree. And this is 90 degree. Okay. So the point B, oops. The point B will be 0A. Now we need to find the point E and the point D. Since they are parallel, So they will be having the same value of the by call this one h. Okay, they will be having a same value h, the point, and they are symmetrical. So if this is a x, then this will be a negative x. Okay, we are not really concerned about the value x because we know that the center of the mass will not fall into the y-axis already. So we just need to concern about the h. We are looking for the h. Okay, so before that, we need to find the AB. Okay, we need to find AB. So from here, from here, since this one is a 45 degree, this one is A, this one is also A. So the AB, just by using Pythagoras theorem, AB is the square root 2 of A. Okay, that is how you get the AB. Then after that, we have the information here, DB divided by AB equal to 1 to K. Then the DB is equal to the 1 over KAB. That means this one, it will be square root 2 over KA. So that is the value of the DB. And the height, the H is equal to the height A minus this height, then you will get the H. Okay. So this is, now the problem is, what is this? What is this height? What is this height? So we need to find this height. Let me erase away. So the height that I highlighted just now, it will be, maybe we can straight away just go for the H. H is actually the A minus the dB cos 45 degree. So dB, just now we found the dB is A square root 2A over K. Then this one is a 1 over sub 2. Then this one, it will become 1 over 1 minus K. Or you can combine them, become A, K minus 1 over K. That is your height, H. Which means that now we have found the coordinate of this. This will look like this, A, K minus 1 over K, and then A, K minus 1 over K. Okay, now we are ready to find the center of the mass. So to find the center of the mass, we build the table. The triangle ABC, the bigger triangle, minus a smaller triangle. Smaller triangle is a DBE. Then the remaining one that you have is ADEC. Since they are using the same material, we are using area will do, no need to use a volume. So for the bigger triangle, it's half times the base times the height. So it will be half times the base times the height. You get this as a square. And the center of the mass from the AC, this one we just apply, take the y coordinate, take the y coordinate, take this value, take this value, take this value, add together, divide by 3, you will get A over 3. Same thing goes for the smaller triangle, DBE. We need to add all together. We need to find the area first. So the area of the smaller triangle is actually half times the base. I call this one the base, I call this one the height. So this one, the base dB, the height BE is the same length. So since dB is square root 2 A over K, so we can just write this one as a half square root 2 over Ka square. Then you will get this one as the A square K square. So the area of the ADEC, just take the first one minus the second one, you get A square. 1 minus this. Now this one is bar y. The center of the mass is bar y. Then the center of the mass for the smaller triangle is, just take this coordinate, add together, divide by 3. So you will get A plus the 2 of the AK minus 1 over K. Let me just write like this. Plus the 2 AK minus 1 over K divided by 3. Simplify it. Then you will get this one as the A over 3. This one, it will be 3K minus a 2. Okay. So this will be the table that I will be using it to find the center of the mass from the AC. Take the moment about AC, then I will get A square, A over 3 minus the A square, K square multiplied by, oh, this one I forgot to put a K. Okay, then this one is a 3K minus 2 over the 3K is equal to the A square, K square minus 1 over K square bar Y. I cancel the A square first. Then I multiply everyone by 3K square, 3K cube. Multiply everyone by 3K cube. Then I will get this one as the AK cube. Then this one is a 3AK plus the 2A. Then this one, it will be 3K and K square minus 1 bar Y. Expand and simplify. I have this bar Y as A K cube minus a 3K plus 2 divided by 3K K plus 1 and K minus 1. Over here, you can actually, you can leave the answer like this. Actually, it's good enough. However, if you are aware that the numerator part can be factorized further, because the root over here, K equal to 1 is a root. Okay, K equal to 1 is a root. That means K minus 1 is a factor. Okay, that means K minus 1 is a factor. So since if you know it, then you can do it like that. That will be making your step easier. So here we factorize the K minus 1 out. Then we have a K square plus the K minus a 2 divided by the 3K, K plus 1 and K minus 1. You can see the K minus 1 can be cancelled off. So therefore, my bar Y will be the A, K square plus K minus 2 divided by 3K and K plus 1. That will be the answer for the part A. Then part B. They say that when the laminar ADEC is freely suspended from the vertex A, the HAC makes an angle theta with a downward vertical where tangent theta equal to 5 over 18. So this is the diagram that we're having now. We have found the bar Y. This is the bar Y. And is the center of the mass fall into the axis of symmetry. So this length over here must be A. This is the point A, the vertex A. And if you hang it, suspend it freely, then the center of the mass, the weight must passes through, the A must passes through the center of the mass. So we go down like this, that will be the weight. And this will be the theta, angle theta, that mixed with the downward vertical. So tangent theta is actually bar Y over A. And given that tangent theta is a 5 over 18, and from part A just now, our bar Y was A K square plus K minus 2. divided by 3k, k plus 1 divided by a. So the a can be cancelled off. So we just take it out. We get 15 over 18 k plus 1 is equal to the k squared plus k minus 2. Cancel the 3. You have a 5 and 6. You have a 5k squared plus 5k. You have a 6k squared plus 6k minus a 12. And you get k squared plus a k minus 12 equal to 0. Factorize it. K plus 4, k minus 3 equal to 0. K equal to negative 4 and k equal to 3. Obviously, k equal to negative 4, we need to cancel it. Okay? Because k is a length, so it will be positive. So therefore, your k is equal to 3. Just like that, done. That will be the answer for the part B. And moving on, a new question, question number 4. Okay, now we look at question number 4. We have two smooth vertical wall meets at the right angle over here. The smooth sphere A with a mass M is at rest on the smooth horizontal surface and is at distance d from each wall. An identical smooth sphere B is moving on the horizontal surface with a speed u and an angle theta with a line of center. When the sphere collide, see diagram, the collision, the sphere takes the same time to reach the wall. Okay, so these are the floor. This is the floor, and this is the wall. Okay, so they have collision. After that, after they collide, A and B, A will start moving, and then B will change the directions of the motion. But at the end, A will reach to this wall, the distance D, and B will reach to this wall over here. The distance may not be D. It's just that the vertical distance is a D. It's just that over here, maybe after that, B will rebound, go until here. Then the time taken, the time taken T and the time taken T is the same. So B, after the collide, it not necessarily must go this way. Okay. So what we need to do now is we need to set up our things over here properly. We have something called before collision, and we have after collision. So before collision, so you have only the B is moving. This is the theta. Then the A is don't have any motion. Both of them having the mass M. So this one is the U. Okay. So this one, it will be in more space. This one will be U cos theta. This one will be U sine theta. So this is the A. After you can still assume that the B is moving this way as well. There is a VB, but this time the angle already changed to become alpha. You can also assume that the B bounce back this way, and you can call this one alpha. Up to you. Over here, usually I will assume that the direction is still the same. It's just that they distorted a bit the directions. So right here, this will be my VB cos alpha. This will be the VB sine alpha. And the VA, after it collide, the VA will go this way. VA have only one directions. Okay. So what you can do over here is that if you consider the horizontal motion, so you will have conservations of momentum before and after. okay, conservation of momentum before and after, which is M U cos theta is equals to the M VB cos alpha plus the VA. So if you write it down, you have a VA plus the VB. Oh, I forgot to write the M here. VA plus VB cos alpha equals to the U cos theta. They didn't give us the value of a theta. They just give us the restitution, the coefficient of restitution between the sphere is half. Okay, so this is what we have for the first equations. And the second equations, we will consider the Newton experimental law, NEL. So you have a E equal to the negative of the VB cos alpha minus the VA divided by the U cos theta minus the 0. And since the E is a half, change the E become half. Then you will have the VB, VA, you will have VA minus the VB cos alpha is equal to the half U cos theta. That will be my second equation. Take the first equation plus the second equation, you will get 2VA is equals to the 3/2 U cos theta, and your VA is equals to the 3/4 U cos theta. Okay, so this is what we have at the moment. But we are looking for tangent theta. We're looking for tangent theta. So what we have here is not enough. We need to understand that after the glide, VA going this way and the VB going this way. But they're having a special features over here is that they actually will reach, they take the same time to reach the wall. So the question mentioned it takes the same time to reach the wall. That means the speed of the A that travel to the distance D and the speed of the B, the vertical distance over here that travel by the B is also D. So we will consider this also takes the time T. This one takes the time T to reach the wall D. This one also takes the time T to reach the wall D. So that means the speed that I'm having here and the speed I'm having here are the same. Okay. So because of A and B reach the wall at the same time, that means what? That means the VA is actually the same as the VB sine alpha. Okay. And for B, if you consider vertically, for B, you consider vertically, your VB sine alpha is equal to the U sine theta. Okay, if you consider the vertical before and after, so the VB sine alpha is equal to the U cos theta. Therefore, you are having VA is equals to the, oops, I write wrongly. It's a U sine theta, not U cos theta. This is a U sine theta. So this one, the VA, by combining these two equations, you will get that the VA is actually equal to the U sine theta. Okay, so this one I will call it number 3. So I call it number 4. So 3 equal to 4. Then I have the 3/4 U cos theta is equal to the U sine theta. U is not equal to 0. Then therefore your tangent theta is equal to 3/4. done. We have found the tangent data. Okay. So once we found the tangent data, now we move on. We can do the part B. Before that, we build the triangle first. Data 3/4, 3, 4, 5. Okay. So from here, we can straight away find the VA. From the equation number 4, we have the VA is equal to the U sine theta. It will be 3/5U. Okay. And then we also know that the VB sine alpha is equal to the 3/5U as well. Okay. Then now we have used the Newton experimental law. We have used the conservation of momentum. What else we have missed out? I want to find the percentage loss in the total KE for the sphere population before and after. So the formula is supposed to be like this. The KE loss is supposed to be half mu square minus a half m VA square minus a half m VB square. I already have the VA, but I don't have the VB yet. I only have VB sine alpha. So means I need to find VB cos alpha. So VB cos alpha equals to what? We need to search for what we have done just now. Where is the VB cos alpha? VB cos alpha is over here. VB cos alpha is over here. So we need to take the first equation and the second equations, solve it again, then we can find the VB cos alpha. So we just take the first equation minus the second equation. Okay. So in order to get VB cos alpha, just take the equation number 1 minus the equation number 2. So you have a 2VB cos alpha, 2VB cos alpha, just focusing on these two equations. So if you minus it, you will get half cos theta. Half cos theta. So your VB cos alpha is 1/4 cos theta. Cos theta is a 4/5 is equals to the, I forgot to write the U. So this one is a 4/5U. So it will be 1/5U. So therefore your VB is equal to the VB sine alpha square, VB square, plus the VB cos alpha square. Okay. Now in our place, I will erase away this statement. So now just apply the result for the VB sine alpha and VB cos alpha. So this one, it will be 3/5U square plus the 1/5U square. If you add together, expand and add together, you get 9/20, 10/25. 10/25, it will be 2/5U square. That will be my VB square. Okay, now we are ready to find the KE loss. KE loss is equal to the half m U square minus a half m VA square minus a half m VB square. So this one, take all the half m out. I have a U square. Just now the VA was 3/5, so it's a 9/25U square. This one, it will be 2/5U square. Use the calculator, simplify everything. You will get 3/25 mu square. This is the KE loss, but they're looking for percentage. So for percentage, we need to percentage of KE loss is equal to the KE that has been lost, this much divided by original KE. at the beginning, the KE initial KE multiplied by 100%. So expand, simplify 24%. So the KE loss is 24%. Okay, done. That will be the question number 5. No, sorry, question number 4. Okay, move on. Question number 6. Question number 5. Okay, now we take a look at question number 5. A bit of mass move on a smooth circular wire. So the wire this is the circular wire. Okay, with a center O and a radius A in the vertical plane. The bit has a speed VA when it is at the point A, when OA makes an angle alpha with the downward vertical, and cos alpha is 3/5. Subsequently, the bit has a speed VB at the point B when OB makes an angle theta with the upward vertical through O. Angle AOB is right angle. The reactions of the wire of the bit at B in the directions of V has the magnitude equal to the 1/6 of the magnitude of the reactions when the bit is at A. Okay, so we are looking for the magnitude of the reaction at B. So over here, we just need to have a diagram over here. First of all, we need to settle the alpha first and the theta, the relationship. They are giving you theta plus alpha is equal to 90 degrees. And they're giving you cos alpha is equal to 3/5. So based on the diagram, we are having alpha 3/5. And since they are 90 degrees together, they are complement angle. They are the complementary angle. So this will be your theta. Okay, so this is the diagram that we will be using after when we solve the problem. And after that, at A, if you resolve the forces, this will be your mg, your contact point. This is alpha, your contact point is over here, so your RA, this will be your RA. So your RA minus the mg cos alpha it will be equals to the MVA square over the radius. Since cos alpha is 3/5, so this one is 3/5 mg plus the MVA square over the A. That will be my first equation. At B, your mg is over here. Then this is the theta. Your normal contact force supposed to be here. Your normal contact force supposed to be go up, go out. Okay, so for this case, your mg cos theta minus the RB, it will be equal to the MVB square over the A. Cos theta is a 4/5. Maybe I should write RB directly. So RB is equal to 4/5 mg minus the MVB square over the A. So at the moment, this is what we have for the reaction at A and B. Then this one definitely need to use the conservations of energy. If you're using conservation of energy, you have a GPE gain is equal to the KE loss. So GPE gain equal to KE loss, it will be half MVB square. No, this one is the GPE. GPE is MGH. So mgh, it will be mg, the height. This is the height. So the height have two parts. One is over here, and another one is over here. So the height is a cos alpha plus a cos beta. A mg cos alpha plus mg cos beta. I think we just direct write a cos alpha plus a cos beta with KE loss half m VA square minus the VB square. Cancel the m. Factorize the GA out. Then you have a cos alpha was 3 over 5 plus 4 over 5 is equal to the half of the VA square minus the VB square. Okay, so your VA square minus the VB square is equals to the 14 over 5 GA. So, okay, this is the third information that we have. Then given that the RB is equal to the 1 over 6 RA. This is what they give you. So you have a RA equal to 6 RB. Substitute them inside from the equation 1 and equation 2. So you have from equation 1 and 2, you are having 3 over 5 mg plus the mva square over a is equal to the 624 over 5 mg minus the 6 mvb square over the a. Simplify them. So you have the all the m can be cancelled. So you have the VA square over A plus the 6VB square over A is equal to the 21 over 5G. Your VA square plus the 6VB square, it will be equal to the 21 over 5GA. That will be my fourth equations. Take the fourth equation number minus the third equation, 4 minus 3. Then I have 7VB square is equals to the 7 over 5 GA. Then my VB square is actually 1 over 5 GA. So I have VB square. I want to find RB. Just substitute my VB square into the RB, into the second equation. Then I have found. So from the equation number 2, my RB is equals to 4 over 5 mg minus mv square over mvb square over the a. So the answer will be 3 over 5 mg. That will be my RB. Okay, done. Then after that, we want to find the value of VA. So from the equation number 4, VA square plus the 6VB square is equals to the 21 over 5 GA. My VB square is 1 over 5 AG, GA lah. So just write 1 over 5 GA. So my VA square will be the 3 GA. VA is equal to square root of 3 GA. Therefore, your value k is a 3. Okay, so this will be the answer for the question part B. Moving on, question number 10, and number 6. Now, number 6, a particle P is projected with a speed u and an angle alpha above horizontal from a point O on the horizontal plane and move freely under gravity. The horizontal and vertical displacement of P from O at a subsequent time t are denoted by x and y respectively. Derive the equations of the trajectory of P in the form of as given as following here. So this one very straightforward. We just need to find the horizontal displacement. It will be x equals to the u cos alpha t. Then from here, I change my t to become x over the u cos alpha. First equations, resolve the vertical displacement. You have y equal to the u sine alpha t minus a half g t square. That will be my second equation. First equation into the second equation, you will get y equal to the u sine alpha x over the u cos alpha minus a half g t square. Simplify it, you can get x tangent alpha minus a g x square over the 2u square cos square alpha. So therefore, this one will be x tangent alpha minus a g x square over the 2u square secant square alpha. Okay, so this one we have shown. Okay, then part A done. Now part B. During the flight, P must clear the obstacle of height h meter and the horizontal distance of 32 meter from the point of projection. The u is 40 sub 2. Then P just clear the obstacle, exactly that height when the u speed is 40 sub 2. When the u is 40, only 80% of the height required is achieved. Okay, so find the two possible values of h. So first of all, we just use the result that we have found just now over here. So okay, when the u is equal to the 40 sub 2, my x is equal to 32, my y is equal to h. That is the first statement. So just substitute in, you get h is equal to the 32 tangent alpha minus a g x square over the 2u square secant square alpha. You need to understand that secant square alpha can be written as tangent square alpha plus 1. Okay, yeah, we can write it like this. So we shall change it to tangent square alpha later. Simplify. You have just copy down this first few statement. This one a bit troublesome. We simplify them. So if we simplify them, you will get this one as the 8 over 5 of 1 plus tangent square alpha. That will be my first equations. Then when u is equal to 40, x is equals to 32, and the y is only 80%. 80% is 4 over 5 of the height achieved. Okay, so this is another information. Just change it, the height become, the y become 4 over 5h equals to the 32 tangent alpha minus the 8 over 5. 8. No, this one not 8 over 5. 10 x square over the 2u square. simplify it. And press the calculator, you will get 16 over 5, 1 plus the tangent square alpha. That will be my second equations. 1 into 2, very obvious. You will get 4 over 5, no, in our place. So you will get 4 over 5 of the H, 32 tangent alpha minus the 8 over 5, 1 plus the 6, 1 plus the tangent square alpha. Equals to 32 tangent alpha minus the 16 over 5 of 1 plus tangent square alpha. Expand and simplify. Okay, so we just need to take some time to expand and simplify. Join all the tangent alpha together. Okay, so from here, we factorize the 4 out, make it like this. So this one is 8 tangent alpha minus the 2 over 5 minus the multiply. Take the 16 over 5 out. I get a 10 tangent alpha minus the 1 plus the tangent square alpha. Okay, so cancel this. Then I have the multiply by 5. I get 40 tangent alpha minus 2 minus the 2 tangent square alpha. I get 50 tangent alpha minus the 5 minus the 5 tangent square alpha. Simplify it. 3 tangent square alpha minus 10 tangent alpha plus a 3 equal to 0. Factorize it. Then you have tangent alpha equal to 1 over 3 and tangent alpha equal to 3. No more square. Okay, just like that. So, I haven't finished it. When tangent alpha is equal to 1 over 3. So I need to use this triangle. 1, 3, set 10. So what is my H? The H you can substitute into the first equations. It will be 32 tangent alpha minus the 8 over 5 of 1 plus the tangent square alpha. Just press the calculator only. From here, you will get the answer as 80 over 9. Then when tangent alpha is equal to 3, you still will get the same diagram, but only the arrangement are different. Then from the first equations, my H will be the 3 over 2 times 3 minus the 18 over 5 minus the 8 over 5 of 1 plus the 9. So you have 80. Done. These are the two possible values of the height. Okay, that is the answer for the part B. Moving on, question number 7. Okay, now we take a look at question number 7. The particle P of mass M attached to one end of a light rod of length 3A. The rod is length 3A. The end of the rod is able to pivot smoothly about the fixed point A. The particle is also attached to one end of a light spring of natural length A and the modulus of elasticity kmg. The length of the spring is A, only A. The other end of the spring is attached to a fixed point O. The point A and B are on the horizontal line, a distance of 5 meters apart. And these 2 points and the rod are in the vertical plane. Initially, P is held in equilibrium by the vertical force F with the stretch length of the spring equal to 4A. See diagram. The particle is released from rest, and in this position, it has a speed of 6/5 square root 2 ag. So this, after this, it will go like this. Then the spring, this one is 3A. Now this one has only become 2A. Okay, so your original length of the spring is A. Your extension is from 3A, move to 2A, move to A. Okay, then your lambda is a kmg. Okay, we are looking for the K. So over here is the motion over here is involving energy. So we will be using conservation of energy. The EPE loss is equal to the KE gain, because the KE at first is at rest. After that, the speed and become this KE gain, plus that the height also gain, GPE gain. So the EPE loss, it will be lambda of the X. This is the X1. This is the X2. So X1 square minus the X2 square. So 3A square minus the A square divided by the 2L. 2L is 2A. KE gain is a half M. Your speed at the beginning is at rest. Then at the end, it will be 6/5 of square root 2 ag square minus the 0 square plus the mgh. The height. This is the height. So the height that means we need to have a data. Okay, so over here we need to have a data. I will call this a data. Then it will make this a data. This is also a data. So the height is actually 3A cos theta. The height is a 3A cos theta. I want to settle the data first. I need to settle the data first because the data is, from here we can just draw a diagram. You have 4A data, 3A, 5A. Take away the A because it's the same ratio. So this is the diagram that we'll be using. So your cos theta will be 4/5. So expand simplify. This one expand simplify. You have 4kmg, 4kmga. This one, it will be 36/25 mga. Then plus the 3 mga cos theta just now was 4/5. All the mga can be cancelled. Wow, so nice. Okay, so 4k is equal to the 36/25 plus the 12/5, 60, 96/25. 96 divided 4, 24/25. That will be the answer for the K, for the part A, done for the part A. So now move on to the part B. F in terms of M and G. So the diagram, we put this. This is the tension of the string. This is the F. Just now I call this one the theta, right? So this will be the theta as well. Okay, so this one is the dotted line. The mass mg. Then there will be a tension here. Tension from the rod. They are 90 degrees to each other. You are looking for F. We need to know the T1. T1 is the tension of we do not know the tension of the rod yet. Okay, so the T1 is the tension of the spring. The spring, because the stretch is 3A. So it will be lambda x over L. So it will be kmg. K we already found. The stretch is a 3A. So this one is a 72 over 25 mg. T1. So to find F, we resolve the forces along the spring. Okay. Along the spring. Okay, we resolve the forces along the spring of direction so that we don't need to get involved on the T2. So if we resolve the forces this way, we have T, then I need to settle the theta. Yeah. So over here, if we do it this way, I need to settle the theta. This is the theta. Okay, so it will be D is equal to this is the theta. So it will be F sine theta plus the mg sine theta. If we resolve this way, along the spring, we resolve that in the directions along the spring. So your D1 is already 72 over 25 mg. Your sine theta just now was 3 over 5 plus the 3 over 5 mg. So your 3 over 5 F is equals to the 72 minus the 15 72 over 35 minus the 3 over 5. Nineteen over 5. Wait, sorry. 72 over 25 minus the 3 over 5. Change it to the fractions, 57 over 25. Then my F will be the 19 over 5 and G. That will be my F. Okay. Then for the tension in the rod. Tension in the rod, we can resolve the forces horizontally. So if we resolve the forces horizontally, it will be D1. Okay, I clear the diagram here. So you can see that actually I do not need to be so complicated anymore, because if we resolve the forces horizontally, then it will be D1 cos theta and D2 sin theta. Okay, so D1 cos theta is equal to the D2 sin theta. So your D2 is equals to the D1 cotangent theta. D1 just now was 72 over 25 mg. Cotangent theta. Cotangent theta just now in the table, cotangent theta is 4/3. So just simplify it. 72 times 4 divided by 75. 96/25 mg. Okay. So done. That will be the answer for the question number C. Number 7C. Yeah, done. Then I move on. Oh, no more. Okay. So I stop the video here.